On July 1st, 2025, a telescope in the Chilean mountains caught something moving across the sky that didn't belong here. It wasn't from our asteroid belt. It wasn't a stray moon. It was traveling at 137,000 miles per hour, on a path that no object born in our solar system could ever follow. Scientists ran the numbers twice. The trajectory was hyperbolic, meaning nothing in our solar system had the gravitational pull to send it on this path. It came from somewhere else entirely. From another star, another world, another part of the galaxy we will never visit. And here's what makes this feel genuinely strange to sit with. By the time you finish watching this video, that comet will have put another few thousand miles between itself and us. It passed through, said nothing, and now it's leaving. Forever. This is the story of 3I Atlas, the third interstellar object ever confirmed in human history, and what it might be quietly telling us about the universe. The Atlas telescope wasn't designed to find interstellar visitors. Its job is planetary defense, scanning the sky for asteroids that might threaten Earth. On most nights, it catches rocks that belong here. But on the night of July 1st, the software flagged something unusual. The object was fast. Way too fast. When it was first spotted between Jupiter's orbit and the inner solar system, it was already doing 137,000 miles per hour. And it was accelerating. Astronomers pulled archival data from 3 different telescopes around the world and traced it back to June 14th, 3 weeks before anyone realized what they were looking at. It had been hiding in plain sight, passing in front of the dense star fields near the galactic center where it was almost impossible to distinguish from background noise. Within days of the announcement, the Hubble Space Telescope locked onto it from 277 million miles away. What came back was an image nobody expected. A teardrop-shaped cocoon of dust trailing off an icy nucleus. Not just a rock. A comet, actively shedding material, already responding to our sun's heat despite coming from somewhere billions of light years removed from it. This was the third interstellar object ever confirmed. The first, a strange cigar-shaped thing called Oumuamua, showed up in 2017 and left before anyone could study it properly. The second, a comet named 2I Borisov, passed through in 2019 and actually broke apart as it left. 3I Atlas was different. It was larger, faster, and more active than either of them. And scientists had more time, more telescopes, and more curiosity than ever before. The nucleus of 3I Atlas sits somewhere between 1,400 feet and 3.5 miles wide. That range sounds large because the comet is so active that the surrounding cloud of gas and dust makes it hard to measure the solid core directly. What surrounds that core is a coma, a glowing envelope of outgassed material that stretched to roughly twice the diameter of Earth. And it has a reddish color. The same reddish color as the previous interstellar comet, 2I Borisov, and the same as a class of asteroids in our own solar system. That color comes from irradiated organic compounds called tholins, ancient carbon-rich molecules that form when ices are bombarded by cosmic radiation over very long timescales. Very long timescales. Based on the speed at which 3I Atlas is traveling and its trajectory, astronomers traced it back to a region called the thick disk of the Milky Way, a population of old stars that formed billions of years before our own sun. The NASA Center for Near-Earth Object Studies director Paul Chodas put it this way: objects like this take millions of years to wander from one stellar neighborhood to another, so it has likely been drifting through space for hundreds of millions, perhaps even billions of years. If that's correct, 3I Atlas might be the oldest comet ever observed. Older than Earth. Older than our sun. Built from material that formed during an entirely different era of the galaxy, when the stars being born looked nothing like ours. But there's something stranger still. The dust tail points toward the sun, not away from it, which is what you'd expect. Solar wind and radiation pressure normally push a comet's tail outward, away from the source of light. But 3I Atlas is expelling large, heavy dust particles at slow speeds, roughly 1 meter per second, and they're falling sunward instead of being pushed back. This isn't how our comets behave. Astronomer Bryce Bolin noted that the particles are hundreds of microns wide, too heavy to be blown away. The comet is weakly active compared to solar system comets, and the physics of that is still being worked out. The path 3I Atlas took through our neighborhood was brief but spectacular. It swung inside Mars's orbit and reached its closest point to the Sun on October 29, 2025, passing within 203 million kilometers. That's about 1.36 times the Earth-Sun distance, close enough for the Sun's heat to do serious work on the comet's outer layers. And then something unexpected happened. Instead of fading, it got brighter. By early November, observers were recording it at magnitude 11.5, roughly 20 times brighter than the official predictions. Some reported brief, violent outbursts where the brightness spiked even further. The explanation took time to work out. The Sun's heat doesn't penetrate a comet instantly. It takes weeks for warmth to work down through the hardened outer crust, which had been frozen solid in the near absolute zero vacuum of interstellar space for possibly billions of years. When it finally reached the deeper layers, ancient ices that had never been warmed before began to sublimate all at once. In December 2025, NASA's SPHEREx infrared telescope caught the comet still violently erupting, 2 full months after perihelion. The outgassing contained water vapor, carbon dioxide, carbon monoxide, methanol, cyanide, methane, and rocky material. Pristine chemistry from a world that never touched our sun before, preserved since before our solar system formed. Meanwhile, observatories across the entire solar system were watching. NASA's Parker Solar Probe tracked it from October to November. Europa Clipper caught it from about 102 million miles away. ESA's Mars orbiters photographed it from close range and submitted astrometric data to the Minor Planet Center. The first time measurements from a spacecraft orbiting another planet had ever been officially accepted into that database. And in late November and early December, X-ray telescopes XRISM and XMM Newton picked up something new: a diffuse X-ray glow surrounding the comet's nucleus. 3I Atlas became the first interstellar object ever observed in X-ray light. There's one more thread worth pulling here, even if it's a short one. Harvard astrophysicist who has become something of a professional skeptic of conventional explanations for unusual space objects suggested early on that 3I Atlas might not be natural. He questioned whether its brightness could stem from self-luminosity rather than reflected sunlight. And in one paper, he wrote that if the object had active intelligence, the consequences for humanity could potentially be dire. NASA was direct in its response. It looks like a comet, behaves like a comet, and has a coma and icy nucleus consistent with a comet. Loeb himself later walked it back, acknowledging that the simplest hypothesis is that 3I Atlas is a comet, and framed his earlier papers as a call to maintain curiosity rather than a firm claim. The scientific consensus is clear, but the fact that the question was asked at all reflects something real. We genuinely don't have a full playbook for how interstellar objects should behave. Each one has surprised us in some way, and 3I Atlas has been no different. Right now, in February 2026, 3I Atlas is drifting through the constellation Gemini at around magnitude 15, too faint for most amateur telescopes but still visible to professional observatories. It's decelerating slightly as it climbs away from the sun's gravity, but once it crosses out of the solar system's gravitational reach, it will resume its cruising speed of around 130,000 miles per hour. In March 2026, it will pass Jupiter at about 0.36 astronomical units. After that, the outer planet crossings come one by one: Saturn, Uranus, Neptune, and then nothing. Interstellar space, in a direction no human-made probe has ever gone. It will never return. It entered our solar system from outside the galaxy's common plane. It was flung here, probably billions of years ago, by a gravitational interaction with a massive object near whatever star it originally formed around. It drifted across the galaxy in the dark. It passed through here, close enough for us to watch it erupt and shimmer and change color, and now it's leaving. We will not see it again. ESA is developing a mission called Comet Interceptor which will wait at a gravitational parking spot between Earth and the Sun for a suitable target. The hope is to intercept either a pristine Oort cloud comet or an interstellar visitor. If 3I Atlas had been discovered earlier, there was a slim window to launch something in its direction. The next one might not slip through so quietly. 3 interstellar objects in less than a decade, each one stranger than the one before, each one carrying chemistry and physics from somewhere we will never reach. What 3I Atlas leaves behind is a chemical signature of another world, scattered through our inner solar system in the form of ancient gas and dust, and a reminder that the universe is not static or isolated. Things move through it. Things that formed around other suns in other eras, under conditions we can barely model, pass through here on their way to somewhere else. And with observatories like the Vera C. Rubin Observatory now coming online, capable of detecting dozens of interstellar objects per year, this is just the beginning of that catalog.